presented by Science at NASA. One of the largest human-made permanent magnets in space resides on the International Space Station, or ISS, and it's helping scientists better understand the origins of our universe. The Alpha Magnetic Spectrometer, or AMSO2, is an observatory that is collecting data from measurements of cosmic rays, nuclei from hydrogen up to iron, as well as electrons and positrons that pervade all of our universe. The original AMS was launched on the Space Shuttle in 1998 to test the concept of a powerful magnet, in-depth studies of subatomic particles. AMSO2 was installed on the space station in 2007 with a projected lifespan of 3 years. 8 years later, it's still working, having already measured and categorized almost 140 billion cosmic rays. Studying these particles can help researchers understand their origin in ways not possible on Earth, whose atmosphere affects them. Data has been captured from sources of positrons at high energies that could be evidence of dark matter, an invisible form of matter that makes up most of the mass content of the universe. More data is needed before scientists can better explain these results. This space-based observatory is essential to helping scientists answer many fundamental physics questions. But with AMSO2 now 5 years beyond the lifetime it was designed for, will it last long enough to give scientists the information they seek? Dr. Kurt Costello, the ISS Program Chief Scientist at Johnson Space Center, says, that's why astronauts are conducting a series of spacewalks known as extravehicular activities, or EVAs, in the fall of 2019. AMSO2 uses 4 cooling systems that circulate liquid CO2. 3 of those systems have failed. As Dr. Costello notes, the EVA team here at Johnson has partnered with the AMS team to design equipment and tools that will allow us to safely replace those cooling pumps. If everything goes according to plan, we think we can extend the life of AMSO2 to deliver full-time science operations for the lifetime of the station. Additional time for data gathering and refinement will allow scientists to continue learning more about the origins of the universe. For more on scientific studies being done on and from the space station, go to www.nasa.gov/ISS-science. For more information about the smallest and biggest ideas about our universe, visit science.nasa.gov.
Three, 2, 1, 0. Ignition. Liftoff.
Artemis 1 will lift off from Launch Pad 39B at NASA's Kennedy Space Center in Florida with 8.8 million pounds of thrust, provided by the most powerful rocket in the world, our Space Launch System rocket, or SLS. The uncrewed flight will be the first integrated test of SLS, our new Orion spacecraft, and exploration ground systems at Kennedy. Artemis 1 will send Orion beyond the moon, 280,000 miles from Earth, farther than any human spacecraft has ever flown.
This is not NASA doing this. This is the United States of America doing this program, the Artemis program. And there are companies all across our country that have a part in it. So there is kind of this wave of excitement being generated just by saying, we're going back to the moon.
After the upper stage of the rocket separates from Orion, the upper stage will deploy small satellites over several days to perform science experiments and technology demonstrations. Orion will make its multi-day outbound trip to the moon, propelled by a service module provided by the European Space Agency. Engineers will test Orion's systems on the way to the moon. Then, Orion will fly about 60 miles above the lunar surface, using the moon's gravity and engines on the service module to enter a lunar orbit. After about a month and a total distance of over 1 million miles, Orion will return home, faster and hotter than any spacecraft has before. A primary goal of Artemis 1, ensure Orion safely returns to Earth before we fly with humans. When we do, we'll build our capability for sustainable lunar exploration, preparing us for missions farther into the solar system.
Initially, what we'd like to do is start establishing a presence on the moon. So we're going to establish going back there on a regular basis, and then we'll end up setting up Gateway, and we would launch to the Gateway, and from Gateway, land on the surface of the moon.
We are there for weeks, months on end. And there, we're going to be able to test out all the hardware and the habitats and the hatches and the suits and the rovers that'll allow us to prove out those technologies. The moon will lead the way to Mars, and we should be there within the next couple of decades.
The NASA team, the world's greatest workforce, in 2024 dreamed dazzling new dreams.
Spaceflight is the ultimate team sport.
The exploration we're doing is the first few steps on the path of getting humans to Mars.
Please welcome NASA's 23rd astronaut class.
In 2024, we prepared to leave our boot prints and open new doors of discovery on the moon and beyond.
This was the first of 3 NASA analog missions to simulate a Mars environment.
Never in our wildest dreams did we think that our little ingenuity would last this long.
Space brings nations of the Earth together. That's the power of NASA.
Are you guys ready for an eclipse?
Now we're getting to totality.
We find common ground by looking to the stars.
And liftoff.
And liftoff.
With the help of our commercial partners, we launched into a new era. New things are possible. More things are possible. Our satellites studied the air we breathe, the oceans we share, the land we live on, to help protect our fragile Earth, the only home that we will ever know.
Behold our stunning X-59.
An X-plane that will shape the next era of supersonic flight.
Cutting flight time from New York to Los Angeles in half.
We turned the phenomenal into fact. Giant leaps in technology, leading the way to scientific discovery to unlock the secrets, the wonders, the majesty of the universe.
And liftoff of Europa Clipper.
Europa has the best chance for life beyond Earth in our solar system today.
We can sail on the cosmic sea to far off cosmic shores.
Over the past few days on the International Space Station, we've had an absolute blast pretending to be Olympic athletes. We, of course, have had the benefit of weightlessness. We can't imagine how hard this must be to be such a world-class athlete doing your sports under actual gravity. So from all of us aboard the International Space Station to every single athlete in the Olympic Games, Godspeed!